The visionary aspect of the concept is that for the first time we have put into practice the idea of separating production from logistics and are now using software to provide all the logic that the connecting conveyor technology used to bring into the system.
We believe that decoupling means that you don't have rigid production, where only one product is manufactured. Instead, you have the option of designing the product flexibly, depending on the order situation.
What we're looking at here is a conventional monolithic system. The disadvantages are the mixture between logistics and production, a fixed cycle time, and the always statically existing material flow.
Der immer statisch existente Materialfluss. Das sind die Nachteile. Und deswegen
Due to these disadvantages, this concept is actually coming to an end. It can't be further optimized.
anfänglich war die Modularität im Mittelpunkt.
Initially, the focus was on modularity. We thought about what it would be like if we made a series of identical cells.
Von Zellen identisch ausführen.
Simply put, there are many omnipotent robot cells that are linked to each other, but the linkages are not rigid. They are completely flexible.
I disassemble the system into its components and reconfigure them as required. And then, similar to an organism's brain, I have the appropriate software to coordinate these components.
We took the line apart according to individual process steps, but without me understanding how a production proceeds, I can't write AI software for a production.
The greatest innovation is the software that connects the whole thing.
The focus is on the modular production cells. This is important. Modular, product neutral, cycle time neutral.
We chose a design with 4 robots in this case, but that will probably be different in practice. It depends on the product range that you want to produce with it.
The first thing I do is to separate logistics from production. I'm condensing the part placement to one central place, the warehouse. All necessary production parts are loaded there.
Before we leave the warehouse, we check the whole thing again by driving this light section sensor up here over it and checking the components. The cell itself is product neutral. Only when the cell is equipped with the appropriate gripper does it become product specific.
With the tool store, I can create a tremendous variety of products. This is nothing other than a tool magazine for a product-neutral system. In this case, the plan, the application program, and the tool are provided by the tool store.
The AGV is the decisive connecting element. What used to be a roller conveyor or some kind of lifting shuttle is now an AGV.
With our navigation system, you don't need any magnetic grids, optical track guidance units, or inductive track guidance units, because everything proceeds purely via laser-based navigation.
Where individual components used to be brought to the assembly line, AGVs are now assembled and fill the production cell for this step, completely autonomously, controlled by the software. This is the digitization of production. The AGVs decouple the line. To put it back together again, I need an extremely large software tool, namely our Smart Production Control. This leads to everything interlocking again afterwards.
The difference between this system and the existing concepts is enormous. We now have more software content in it, but that's simply the future. Many things that used to be solved with hardware will be solved with software in the future. So I can imagine that in maybe 5 to 10 years, a pure matrix production will really exist.
The system runs in real time, with the virtual shadow mirroring the real system. I can see if there is a problem, so I can step in and check the component which is clearly designated.
A big advantage of our concept is that because we don't have rigid linkage, we can continue to produce even when a scene is at a standstill simply by reprogramming the material flow. This is particularly interesting for manufacturers who want to produce a large number of different products on their systems, or for customers who don't know yet exactly how the market will develop. For example, it's absolutely suitable for the spare parts business.
I can integrate as many cells as I have space for. That can be 10 cells, that can be 100 cells, but that can also be just one cell. The quantity results from the production requirements that I'm planning. With a system concept like this, you can produce anything that can be manufactured, because the part that's being produced is its own construction plan.
When the product is called up in the production plan, the AGV fetches the appropriate tools, places them into the processing cell, and then we can manufacture a new product in the system.
This matrix concept might then be available in sizes 1 to 10. You can say, for example, that for automotive the size is 5, for shipbuilding the size is 10, so that the size of the finished product determines the size of the matrix concept. That's absolutely conceivable.
For us, this is the first step into the future.
Orange Intelligenz.